Lesson 100, Graphs of Parabolas, page number 413 in your book. All right, yeah, this is a whole new world to a lot of you. Here is a picture of a parabola for you. That's all free. The red line is the parabola. What we're going to be doing today is learning how to draw one of them boogers and be able to draw it clearly and accurately. You will be using parabolas for the rest of your math life. It's interesting about math, isn't it? That everything you learn today, you will need later in math.
Not everything.
So,
Later in math.
well, some of my stories, you know, you can get away with not remembering, but you know, the stuff we do up here, yeah, they're going to hit you sometime, somewhere. May not be a long, long, drawn-out lesson, but you will be expected to at least remember some of it. Okay.
It'll hit you later in math.
So anyway, that's a parabola. Here is, whoa, the standard form of a parabola. That would be good to write down. Y equals ax squared plus bx plus c. Good to know because you can get a lot of information of what a parabola looks like based on the equation being put in that format. It's kind of like quadratic equation, yeah, because it is a quadratic. That's what a parabola makes. So let's go back to my blank screen. A polynomial equation is a quadratic equation if the highest order of the equation is 2. Highest order meaning that the exponent of the equation, the highest exponent, is a 2. Okay? That exponent's a 3 or a 4 or whatever, you're not going to get a parabola. It's not a quadratic equation. So it has to be a 2 as your highest power of the variable. Okay. We have two unknowns. You have to have an x and a y in order to get a quadratic equation, in order to get a parabola, in order to graph it on a coordinate plane. You have to have an x and a y or you don't have a two-dimensional graph with a length and a width, with an x and a y. If it only has an x in it, it's not graphable because you're not even looking at y values. So it's got to have an x and a y in it. So when you've done graphing in the olden days, when you were a wee little tyke, you had this cool little thing here. And if I gave you a graph that looked like x squared minus 8x plus 13, and I set that equal to y, in order to graph that, you'd have to come up with a number for x and have it spit out a y. So you put a 0 in for x and it'd spit out a 13. You put a 4 in for x and it'd spit out a y value. And you do that over and over and over until you got a picture of what that graph looked like. And the problem is you have to do it enough times that you get a good picture of what that graph looks like. So for example, if you had an xy axis and you started graphing, you know, in order to get a graph that looks like that, you're going to have to graph an awful lot of numbers. So it'd be really, really handy if there was a method to look at this and be able to figure out a lot of things about this parabola based on, well, obviously that's not a parabola, but based on just the information there without doing a lot of work. So that's what we're going to, pardon me? What's that about?
So is it really obvious that that's not a parabola?
Because we can't keep doing
Yeah, it didn't have a 2. It had a 2 on it. So it had a quadratic function, which means it's a parabola. The graph, yeah, a parabola always looks like that.
One curve.
Or it can look like that.
Up.
Right side
Or
up, upside down. Okay? So let's move along with what we're going to do here. Okay, so a few things that we're interested in when it comes to graphing parabolas. We want to know, one, whether it opens up or down. Is it a smiley face? Is it a sad face? Okay? We also want to know what the y-intercept is. Okay, so if this is my graph, I want to know where it crosses the y-axis. That's important. Let's see. I also want to know what is called the axis of symmetry. Axis of symmetry is a line that cuts this parabola exactly in half. It makes it symmetrical on either side. It also goes through what is called the vertex. We also want to know where the vertex is. The highest point or the lowest point. They call it in upper level math the min or max, the minimum point or the maximum point. If it looks like this vertex up here, is that the maximum or the minimum? It's a maximum. It's the biggest number y can be. The minimum, is the lowest point that y can be. So, depending on whether it's a happy or a sad parabola, will determine whether you're looking for a max or a min point. So those are the things we're looking for. Those four. Does it open up or down? What's the y-intercept? Where's the axis of symmetry? And where's the vertex? If you're given that much information, all of a sudden you've got enough to graph this. Y-intercept is how many points? 1. But because it's symmetrical, if you know where the y-intercept is on this side, you know where that corresponding point is if you flip it. Okay? So you're really given 2 points knowing the y-intercept. The axis of symmetry. I know where this little blue dotted line is. I also know where this point here is. So now I know pretty quickly whether it's fat or whether it's narrow. I know where it crosses the y-axis. I know its max or min point, and I know where that symmetry point is that it flips back and forth. So I can graph the whole thing just knowing those 4 bits of information. And we can do that rather quickly. So that's what we're going to do today, is rather quickly go through some of this. Okay, so let's go ahead and write an equation up here. Let's see. Let's do y equals x squared minus 8x plus 13. Okay. So, if the number in front of the x squared is positive, in this case it's a 1, right? And it's positive. People with a positive outlook on life are always what? Yeah, so it opens that way. That's the way I remember it. Positive outlook on life, smiley. You have a negative outlook on life, you're a grump. Okay? So, kind of helps, positive and negative. Helps you remember whether it opens up or down. This opens up, this opens down. Okay? So that's not too bad. First part of the puzzle already solved. So this one we know opens up. So that part's done.
Do you know from the first number?
The first number, yeah, the number in front of the x squared. So if that were a -3, it would open down. One thing I want to bring up too, how fat this parabola is. Look at this. As this x value, or a value, the number in front of there changes, look what happens here. As that number gets bigger, what happens to the parabola? It gets smaller. As it gets smaller, it gets bigger, until what happens, it won't be 0. It'll never be 0. Because if it's a 0, what happens to the x squared?
Goes away.
Goes away, which means it's not a quadratic equation anymore. It means it's a linear equation. In fact, let's see if it does that. What do you think it's going to do if I make that a 0?
Make it flat.
Yeah, it's going to make a straight line. Let's see if it does. Ah. Yep, there you go. When I go smaller than 0, negative, it's going to flip upside down. Okay? Okay, so the A value changes as it gets smaller, it gets fatter and fatter and fatter until it's a straight line, and then it starts curving the other way. So it's up like this, fat, small, number gets smaller and smaller and smaller until it's 0 in a straight line, and then it goes. So there's a point in there, at the point where x is 0, that it's not a quadratic function. So that A value can never be 0 and be called a quadratic function. Okay. The parabola crosses the x-axis at this number right here. Okay? The constant term of the equation. When I say constant, it means there's no variable with it. If it's written in standard form, ax squared plus bx plus c, the c value will be where the y-intercept is, where it crosses the y-axis. So if we make this, I don't know what the, oh, okay, there we go. Let's see if I can make this a 10. Down, there we go. So it crosses here at 10. So whatever number this is where it's going to cross. So 25, there it crosses the y-axis.
So it's C.
Another easy part. So yeah, C. So on this one, my y-intercept is 13. So at this point, I've got whether it opens up or down, and I know where the y-intercept is. If this were a negative number, it would cross the y-intercept at negative 13. Okay? So whatever sign is in front of that 13 is also the sign that needs to be drawn along with it.
So that's automatically the y-intercept
Yep. Okay. Now, we need to figure out two other parts. We need to figure out the axis of symmetry. And what was the other part?
Vertex.
The vertex. Yes. So we need to figure out the vertex. So the axis of symmetry and the vertex. In order to do that, we have to make a little bit of a change to our equation up there. And this is where old Algebra 2 comes into play. We have to rewrite this equation as if we were completing the square. If we write it in completing the square kind of form, then we can find those next two bits of information out without actually having to do any work either, except completing the square. Can we what?
No.
Okay. So let's take this equation up there. Thank you. Okay, so if we want to complete the square here and find out that other bit of information, we have a little bit of a job to do here. So, first of all, we need the form that we're trying to put this in. Let me put the form up here. It's at the top of page 416, a couple lines down. Y equals the quantity x plus a, the quantity squared, plus k. That's the format that we're trying to put this equation in order to find our other information that we're looking for. Okay? So we found two of the four. Now we're going to look for the rest of it here. Okay. So, first step. We're going to rewrite it like that. Didn't really do anything to it. All I did was put parentheses around x squared minus 8x and took the constant, the plus 13, and put it outside the parentheses. Now what I'm going to do, following completing the square, I'm going to look for that third term inside those parentheses. What is that third term? How do I find it?
Half of 8.
Half of 8,
And then square it.
and then square it.
So plus 16.
Okay, can I just add 16 to the problem? I mean, if this answer were 12 and I added 16, is it still equal to 12? No, it's equal to 12 plus 16 now, right? So I can't just add 16 there.
I get that to the other side.
I could, but that's not going to put me in this format because now I'm going to have a y plus 16 on that side, which is not what I want to do. So what I want to do is I want to add it to the right-hand side and subtract it from that side. So then I've added nothing, right? So, but in order to do that, in order to do what I need to add it to inside the parentheses, subtract it outside the parentheses. So I added it, but then I subtracted it later on. Okay? Which allows me then to write this as x minus 4, the quantity squared, because remember when you complete the square, you write the x, the first sign, which is our minus sign, half of the second term is a 4, put a squared sign. 13 minus 6 is negative 3, so I'm going to put a minus 3 here. And now I am in this form right here on the far right. So now I can get some information out of this. Okay, so it opens up. If you go all the way to this before you even decide whether it opens up or down or anything, you can look at the sign in front of this. And because it's a positive sign or no sign, you know it opens up. Your axis of symmetry. Your axis of symmetry, where, and this is, I'm sorry if this gets into a little bit of calculus. I'll try to be careful. The axis of symmetry always goes through the vertex, right? The maximum or minimum point. So my axis of symmetry, I know, is going to go through that vertex. So, what you're going to do is your axis of symmetry is always going to be what makes that 0. What's the slope of the line at the vertex? 0, right there. So what I'm doing is I'm trying to find a number to put in there for x that's going to make x minus 4, 0. It will always be the opposite sign of this. So if that was a positive 4, your axis of symmetry would be negative 4. If it's negative 4, it's going to be positive 4. You're looking at what's going to make this 0. Because in calculus, the derivative is the tangent line, and we're looking for the tangent line where it's 0, and that is always at the maximum or the minimum point of a parabola. You don't have to understand any of that. All you have to know, Madison, what number is going to make that 0. That's all you need to know.
0.
Actually, all you need to know is take this number and change its sign, and you've got your vertex.
And that's your vertex.
And that's my vertex. Okay? So I know that this vertex is this is my x-axis. It's 1, 2, 3, 4 over. Okay? And it's going to be straight up that way.
So the axis of symmetry and the vertex.
The axis of symmetry is the x value of your vertex. So if this is my axis of symmetry and it's x equals 4, and an axis of symmetry will always be x equals something. So we come over 4, we draw a vertical line. If I'm looking for this point right there, it's going to be 4, 0. So my axis of symmetry and my x value of my vertex are the same number. Yes.
So for our thing, does the x, so number 3 and 4 are both 4?
No. The axis of symmetry is 4. The vertex The x part of the vertex is 4, but we don't know what the y value is. We know it, we come over 4, but we don't know how far up or down we go, and that's the next point here. Okay, the number here, -3, that I circle or put a square box around, that number is the y value of your vertex. What's my x value up there of my vertex? 4, right here. My y value of the vertex is that number, so -3. Okay, so my vertex is 4, -3. So really, I did the completing square, but I didn't have to solve anything. I just rewrote it in another form and took information off of that.
So you changed the 0 to a -3.
Well, that 0 up there was just if this were at 0, that's what it would be. Okay, so let's do one.
Wait, didn't just do it?
No, well, we did kind of. Let's do
That was
let's do
one.
another one. That was more of an explanation. Now we're gonna.
Like, oh my
I'm
God.
gonna melt down.
I spaced it out.
Okay. First step. Write the equation in standard form. So it has to be in this form. A squared plus bx plus c equals y. Okay? Once it's written in that form, now you can start getting information from it. So, 1, does it open up or down? Okay. 2, what is my what is my y-intercept?
2.
Okay, so my y-intercept is 2. Okay, actually it's 0, 2. That's the point. It's on the y-axis, which means I didn't go anywhere left or right on the x-axis, so it's 0. So 0,
Should we
2.
specify that?
Yeah, it's always good to write it in that way. Or you could just write it as, yeah, write it as 0, 2. All right, next step is complete the square. So, first step is parenthesis. Plus 2. Next step, half of the middle term squared. Whoops. -4. Next step. Put it in that form there. Once you get it in that form, you're ready to go. So, at that point, my axis of symmetry is what? My axis of symmetry is whatever makes that 0. So, that would be 2. In 4, what I'm looking for there is my y-coordinate of my vertex.
It's -2.
So my y-coordinate of my vertex is -2. What's my x-coordinate of my vertex?
2.
It's always the axis of symmetry.
How did you know?
Why is the first
How did
one
you find
not
out
negative
the,
two?
the y?
What's that, Alex?
Why is the first one not a negative?
This one here?
No.
This one?
Yes.
Because I'm looking for the number that makes this 0.
Got it.
So 2 minus 2.
Why? How did you not find the second number?
How did I find the second number?
No, the first.
No, the second.
Right there. Always the last number.
So your axis is the same as your x.
Yes, exactly, Erica. Yeah. Okay, so once that's done, yes, Caleb?
Access 2, 0, or is it just 2?
It's just 2. Yeah, good point. Because my axis of symmetry is a line, it's only x equals 2. If I gave it a y variable, if I gave it an x and a y, it would be a point. Okay? So it has to be just the x, and it will always be an x. It will never be a y equals.
Wait. This is from the vertex?
Yes.
So, alright, now I'm confused.
Well, stop it. Okay, let's look at this. What is my a value? What was the number in front of x squared in the original equation?
0.
1.
1.
1.
It was a
I
1?
said first.
Okay. What was my b value?
Negative 4.
Negative 4.
Said first.
Okay. And my c value?
Yeah.
What was the c value?
Points. Add 2
2.
more points.
There's your line.
Okay. So, what did I say my axis of symmetry was?
2.
2, which is right there. What is my y-intercept?
0, 2.
0, 2, right there. Okay. And my vertex?
X2, Y
What's my x value? 2.
Yeah.
And then it was, so it was 2, negative 2?
Yeah, sure.
Okay, so at this point, I only know 2 points. I know my vertex, I know it opens up, I know my y-intercept, but that's it. But,
But
look
since
at this,
it's a line
guys.
of symmetry.
Since, yes, thank you, Riley, since it's a line of symmetry, this is 1, 2 over here, so I know it's 1, 2 over here at the same height. Okay? So I can then, knowing this bit of information, just give me kind of a real basic idea of what my parabola looks like.
Should we draw that out?
Yeah. And when you draw
What
it,
about the line?
Just give me a second.
the blue line, yeah, yeah.
I wrote the website.
So that's all you're drawing there.
How do you draw that?
Good question. How do you draw this?
Yeah.
We
You just said a bunch of numbers.
my
and then
content,
you go, "That's
pictures.
the line."
Okay. So let's start at the beginning. We got it that it opens up. All right. What's our
Y-intercept?
y-intercept?
2?
2.
0, 2.
Okay. What's my axis of symmetry?
2.
This is what you do in your homework. Okay. What is my vertex?
2, negative 2.
Okay. That's all you're getting, right? So now I look and I'm like, okay, this is 2 over, so this is 2 over. And then I just go.
Oh,
like
you
that.
just make up one.
Yeah. Yeah. Yeah, the other one was different because look what they did. They've got 2, 4, 6, but here they went 10, 20, 30. So
Can you go
it
back
got
to that?
big faster. Okay,
Yay.
so that's all you're drawing.
2, 0, 2. Oh, wait, where did you put that dot at?
What dot?
0, 0,
0,
2
2.
here.
2. Ah.
Okay. I'm going to give you one more and let you do that on your own. Or we could go into the next lesson. Which one do you want to do that?
on our own.
So,
Mine is back to what is the next lesson?
Just not.
the next lesson is lesson 102,
That was 103.
which is sums of functions and products of functions, which you don't want me to do that today. Okay. I'm going to put this up here before you get started. Before you even get started here, what is the thing that you don't like up there? The negative in front of the x. Okay?
So
It
should
tells you all of a sudden that it's going to go
A frowny.
a frown, yeah, it's going to go down, it's going to open down. But other than that, we don't even want it there because it makes life miserable. So if there's an x in front of here, switch all the signs.
I don't like that. I like that a lot worse.
There. Now we're going to ignore this until the very end, and we're going to do just that.
So can we stop?
I'm done.
It's
30-minute video. Kendra's going to love this.
Because 1
Okay.
minus 1.
So, from this equation up here, we know my y-intercept is 2. And I know that it opens down because of that. So I just remember that. Okay, from this equation right here, I know that my axis of symmetry is what makes this 0. So 1 minus 1 makes that 0. So my axis of symmetry is x equals 1. Okay, so whatever makes that 0 is my axis of symmetry. This number here, I know that my x value is 1 for my vertex.
What?
My y value is this number. So at 1, 1, 2, 3, that point right there is my vertex. And it ends up being my maximum because it opens down. So now I'm going to reflect across the axis of symmetry there and get a parabola that looks
Looks like a
like
mouse.
that. It looks like a mouse.
So where's the y-axis?
Y-axis is right here.
Where is the point on it?
The point is 2, right there.
I know that I'm gonna miss a lot of these.
What's that middle point?
Yeah.
This point here,
Yeah.
that's point
I'm
1,
still not
3.
exactly sure what it's supposed to be.
Yeah. So, let's see if we can
You should pause it.
Do